Good morning, dear students. Today we will see how to write a VHDL code for finite state machines, that is FSM. In earlier class we have seen there are two types of FSM, Murray machines and Mealy machines, and we have seen a common template which can be used for Murray as well as Mealy machines. Now we will see one example. This is an example of BCD counter. Means there is one counter which is counting from 0 to 9, and after 9 it will become again 0 with the rising edge of clock. Whenever you will apply a rising edge of clock, it will change its state from state 0 to state 1. When for a next rising edge, it will from 1 to 2. With the next rising edge, it is from 2 to 3 and so on. In between, if you apply a reset, it will go to the state 0. Now, for this particular example, that is a BCD counter, we have to write the VHDL code. If we want to write a VHDL code for this BCD counter with the help of FSM style that we have already studied, that is upper part and lower part. Upper part and lower part. If you remember the previous lecture, in that lecture the upper part was a combinational circuit and it has an input, and below part was a sequential circuit and it was means what you can say, whatever the next state is over there, it is assigned to a present state. A very simple working of the lower part. Now we have to write the VHDL code of BCD counter, keeping in mind that how the FSM works. With the help of the templates, you may say design templates for FSM. Let us start writing the VHDL code for the counter, BCD counter. Rather, instead of saying counter, let us say BCD counter. Entity counter is port, clock, reset. There are two inputs, clock and reset. I told you that for every rising edge of clock you are counting, means for every rising edge your state machine will enter from one state to another state. And it is a BCD counter, hence there will be the four outputs. There will be four outputs. Hence the out is being, the count out is declared as a steady logic vector 3 down to 0. End entity, that is a counter. Now whenever you want to write the VHDL code with the help of FSM style, then you are using a state and this state must be declared. The state must be declared. Hence, in the architecture part, hence the declarative part of architecture is consisting of these declarations of state. Here the architecture state machine of counter is, the name of architecture is state machine, and you can see that before keyword begin there are certain declarations. What are these declarations? The declaration is of a type. What is the name of this type? The name of the type is state. And what values the state can take? These values are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Means this type state is user defined type, user defined or user declared type, and it can take the values from 0 to 9. There are another declarations. It is of signal. Two signals are being declared, that is a present state and next state, and these signals are of the type state. Means whatever your VHDL code is over there, in your VHDL code, wherever you are going to use present state, PR underscore state and NX underscore state, these two signals can take the values from 0 to 9 only. No other values can be assigned to this PR underscore state and NX underscore state because they are of the type state. Now let us see the VHDL code. The process lower section. The lower section is a sequential section, and the sequential section is dependent upon reset and clock. As already discussed, that if reset is applied, then your present state must be the initial state. Hence, if reset is equal to 1, then PR underscore state is assigned 0. But if reset is not applied, then what to do? Whatever calculated next state is over there, it is to be assigned to the present state with every rising edge of clock. Hence the statement is written as else if clock tick event and clock is equal to 1, then present state is assigned with next state. End of end process. This is the lower section of your FSM. Now the upper section is dependent upon present state and input. In this case, there is no external input is being used. In this case, there is no external input is used. Hence, we can say that it is a Moore machine, M-O-O-R-E. Now you can see the upper section, which is a combinational one, but still we are writing the VHDL code with the help of process. And this process will depend on present state as there is no input. Hence, in the sensitivity list also, you will find only the present state. Process begin. Case present state is quite obvious. I have to describe, or the programmer has to describe, what will happen in all these states from 0 to 9. Let us see how we have written that. When the state is 0, what are the sequential statement with respect to this state 0? There are two statements. One is count is assigned 0 0 0 0 in double inverted comma, and whenever you are in present state 0, your next state is 1. Similarly, when your state is 1 at that time, count is a STD logic vector 3 down to 0 of 4 bits. Hence, I told you that whenever you are using more than 1 bit, you have to write its value in double inverted comma. That's why when the state is 1, at that time your count is assigned 0 0 0 1 in double inverted comma semicolon, and your next state is 2, and this will continue till the state 9. What will happen when the last state, that is 9, will come? Your output is that is a count as 1 0 0 1, and your next state is 0, and it will repeat again. End case, end process, end state machine. Thank you.